Hi, everybody. Wanted to go over how to do that spreadsheet. The most important thing is to set yourself up with the fields. So on the top, you're going to have your planet name. I like to go 2 down and 2 across just to leave myself some space. Planet name. Okay. Then I'm going to have my mass of planet. Most important thing is in parentheses, put the units. We're going to be using kilograms. Move across. Radius of the planet. We're going to have that in meters. Move across. And this is going to be our first calculation column. This is where the gravity of the planets are going to be red. And that's going to be meters per second squared, parentheses, move across. And then we're going to say gravity compared to Earth. And it's going to be unitless. And the last one's going to be weight of person on planet. Okay, and that one's going to be in newtons. Okay, guys, just remember these fields they look like they're going to overlap, and we'll fix them up in a second. But whichever one that you can click on, you can fix the details at the top here even better. Newtons, awesome. Now, those are going to be all my fields. What I want to do is stretch them out to the point that every one of them can be seen. And then if I click on each one of the columns, I can drag them closer and make them nice and visible. Okay, what I want to do is, I mean, you can leave this space here if you want to include Pluto, whatever. But I want to leave a constant, which I'm going to use in all my calculations in this spreadsheet. Remember, we're modeling the gravitational forces that occur in each one of the planets. So this is going to be our universal gravitational constant, or G constant. And that is a value of, because we're going to do some exponents, we'll put the equal 6.741. And in order to show multiplication, we use the star key. If we want to deal with division, then we use the slash. Okay. Times, it's a very small number, 10, and it's an exponent. So if we want to write that exponent, we use this character, and it just happens to be that this constant has been calculated to be to the power of -11. Okay. Enter that and you get a 0. But if you look at the top, you can see all your digits have been entered. So what has happened there is you're going to have to go to the formatting of the number. And then as you scroll down, you're going to have to click that you want to see it scientifically. If you want to see all your figures or reduce the number of figures, you play around with these decimal numbers. So we can see we can reduce it or we can increase it. Okay. Okay. Enter in the website that was given to you. It will take you to a model of the solar system. Looking for the planet that you're entering, we're doing Mercury first. So we found Mercury. We got all the information. We got the length of its year compared in Earth days, its distance away from Earth, how many moons it has. It's got a whole variety of information here that you'll probably be using throughout this term. But if you scroll down, then you get more information. You can open these up in your windows. and you get a bigger detail of the planet that you're looking at. Scroll down. You really want to go into by numbers. Gives you a whole heap of information. And what you're looking for are equatorial radius and mass. Okay. Because this is written in kilometers, we have to convert them into meters because the model works only in meters. So there's a couple of ways you can do it. You can find a converter online, or you can use your intuition and understand that there is 1,000 meters in a kilometer. So that means all you have to do is add an extra 3 zeros to that decimal points. So let's say the radius we determined was, or we figured out was this 2,439.7 kilometers. We added an extra 3 zeros following that decimal point. So we carried that decimal point 3 over. So we went 1, 2, 3. And that made it into meters. So that was that, got rid of that decimal point. And now what we need to do is convert it into an exponent. So the way we do that is we could include all our important figures, and we usually in scientific notation just leave the first number as the important I guess number at the front. So we got 2.4397. These are all significant figures. They're very important that we have to keep in order to maintain the accuracy of the information that we got. We multiply that by an exponent, and what the exponent is a count of decimal places. So we have, from the 2, we have 1, 2, 3, 4, 5, 6. So it's positive 6. Let's have a look at our mass. We do the mass. And again, guys, if you are okay with this, then move on in this video. And that was in meters. So we're going to convert it into scientific notation. 104 times 10. And let's see how many numbers I have to include in the exponent. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. All right. 23, and that's in kilograms. You can see that tidies that up so much. All right, so now we can enter those values in. So the mass, start off with our equal sign. It was 3.30104 times 10 to the power of 23. And now let's move on to our radius. That one was equals 2.4397 times 10 to the power of 6. Now let's calculate our gravity. We have to enter in our equation. Okay, recall that Newton's equation, universal gravitational force, which was force is equal to big G, big M, little m, over the radial separation distance between them squared. So if you had, like we talked about, a planet, some little mass, the entire radial separation between them is r, and each one had a different mass. And the beauty was that Newton's derived quantity of G was his genius, 6.741, times 10 to the power of 11. All right. We're going to use that equation to calculate the gravity on the planet, because we're going to say that every single one of the small masses is equal to 1 kilogram, right? And that gives us a factor that anything that is measured in kilograms can be, I guess, used on that planet to measure the gravitational force that object experiences on that planet. Okay, guys, keep your eyes peeled on the various formats. So for these ones, we decided to go with scientific notation. For these ones, we won't need scientific notations. We want just a clear number. So we'll format that. Just a number. That's all we want. Okay, so again, we're doing a calculations, we're doing something, so we'll start with an equal sign. Best thing to do here is put everything in brackets. We're going to have the top of the fraction divided by the bottom of the fraction. Okay, so let's go to the top. Now the top starts off with a universal gravitational constant. So we click on this block because we've already typed it up. And in order to keep this same constant going through all your calculations as you go down the column, you got to put the money symbol. So you put that money symbol in the beginning and in the middle. That separates the column and the row. Then you're going to multiply it by the mass of the planet, and you're going to multiply it by 1. So we have to include. Then you divide it by the radius, and you're going to square that radius to the power of 2. Enter that, and that gives you the mass. Okay. Compared to, so the gravity compared to the Earth, how many times does Earth gravity fits into Mercury, and the weight of a person in that planet? So let's do those now. Okay. But before we move on, let's put a mass column, right? So this is mass 1, mass 2. Right? Just call it mass 2. I just call it mass of the object, mass of object. It's in kilograms. Let's say smart person is 100 kilograms. You don't want to put any equal signs or any units at the bottom here, because otherwise that will complicate your calculations. Okay, so let's do the ratios of gravity. So we're going to say this value, so we're going to put an equal sign. We're going to say the gravity value divided by 9.8. We're going to say that's the Earth's gravitational value. We enter that. We need to calculate the weight of the person. We go equals, we multiply the mass. And again, we want to have this same number being used all over. So we're going to put the money symbol to indicate that we want the same column, and we want the row, the value in the same row. And we're going to multiply that by the gravitational value. We'll hit enter, and that's done. Now, all you have to do now is enter all the mass and radius values. Then you can just scroll. You can use this this tag and extend those calculations to the other planets once you're done.